I would like to invite Mr. Rajesh Suri. He is the head of design and engineering team at Sterlite Power and is responsible for end-to-end design of transmission lines and substations, driving new initiatives and technologies in the transmission sector. He is a power sector professional with more than 30 years of experience in HVDC and FACTS technology, EHV and distribution substations in the areas of design, engineering, construction, installation, commissioning and operations. Today, Mr. Rajesh will talk about new trends in substation design and engineering. So delegates, let's welcome Mr. Rajesh Suri.
So what I will do is, as you know, Sterlite Power is one of the leading developers of transmission in the country, private sector developers. So I will be giving more of a perspective from a developer point of view for substations, not limiting myself to digital substations. And what I would also like to say is, in today's environment, the substations should be considered as part of the power system. We should be, whenever we talk about substations or any other technology in the transmission sector, we should consider the whole power system as a whole, because what has happened, you can see the slide over here. In the past, what we used to have was just a simple generation station. It could be a thermal or hydro or a nuclear station, and then there was a transmission system to the load areas from there, with a step-down substation built and then connected to distribution substations. But today, the energy landscape has gone a major change. Today, we have generation which could be wind, which could be solar. There's a lot of battery energies in the storage in the systems. Some of the thermal power is still there to provide the necessary inertia to the system. So overall, it's become a very complex sort of energy landscape now. And to do this, a substation, as I said, is not going to be limited to just a step down or a step up substation. When we consider a substation, it could have other elements involved like patch devices and other things put over there to take care of any grid contingencies which could happen. So continuing from there is, as I said, if we consider on an overall power system basis, the problems which we face today with transmission systems are, number one, utilization of existing resources to the maximum extent possible, because we have a certain amount of infrastructure built up and it should be utilized to the maximum extent to keep the end cost to the customer low. Today we have very severe right-of-way constraints. Getting substation land is now a very a difficult task. To build an EHV substation, the land acquisition takes almost about 7 to 8 months. And in some cases, a lot of litigation is involved. And today, with a large number of renewable generation in the grid, the renewable integration has become a major issue today. And of course, all this has to be done with a stable power system. If there's instability, we would be looking at blackouts. And we recently had a blackout in Mumbai last year. And before that, if some of you may remember, in 2012, we had two major blackouts in India over a period of 2 days, where about 60% of the country was without power. So stability also is a very major issue today. And what we would like to have from our transmission system is, that is, the lines, the substations and other devices, is to have a very high degree of, I will not read through all of these, but just to highlight a few facts, is to have a very high degree of availability and reliability to meet all the system requirements in terms of active and reactive power. And in the end, but not the least important, is a low cost to the end customer. If we are able to achieve some of this, then I think the power system engineers in this country are doing a very good job. So when we go into a development of substation design, the issues which are faced by the design engineers, this is apart from whatever equipment has to be put into the substation. One is, of course, the space constraints. Land is at a premium today. With more and more substations and lines and system elements coming in, short circuit levels is becoming a major concern at all substations. For example, some of the older substations where the buses are rated for 25 kiloamperes, today the short circuit levels of some of them are close to 50 kiloamperes. Some of the stations in the NCR are facing this constraint, and operations are being done by a split bus just to ensure that there's no untoward incident in the substation. Another thing is to keep the O&M expenditure as low as possible, and of course the condition monitoring of the equipment. Another issue which is causing a lot of challenges today is the approach how to bring the line into the substation. With more and more urbanization and development happening, getting the lines into a substation is a huge challenge today. In fact, in some areas, the last mile connectivity today is being done through cables as high as 400 kV, because there's no corridor available for the transmission line. And of course, the other factor is the reactive power, because what is happening is today, with a large network of 765 and 400 kV in this country, nighttime when the load is very low, some of the regions have severe overvoltages. And to control those overvoltages, the only option is to switch off the lines, which in case of an emergency could have an adverse impact on the grid. Substation land challenges, as I mentioned, are happening due to large amount of urbanization today, economic element, and probably a more better awareness of stringent social and environment regulations. There is a larger public awareness today of where the substation land is. And the last is, of course, this has all made the selection of a substation task a very complex task today. And for this, what we need is probably some new way of thinking to overcome the space challenge. One of them, of course, which has been present for a long time, is using GIS substations, the gas insulated substations. Other concepts which are coming into the market today are you have either indoor GIS substation, an outdoor GIS substation, or a hybrid GIS substation, which is a mix of AIS as well as GIS. Multi-level vertical GIS substations. Sterlite Power has been a pioneer in this. In the Gurgaon area, we have built 3 vertical substations, which against a conventional land requirement of about 12 acres. The substation has been done in a space of 3 acres. Also today, perhaps the way we design this, something for the regulators to see, is how we design our busbar switching schemes. Today, the equipment we have available in the market, whether it is circuit breakers, disconnectors, have a high degree of reliability. And perhaps a call could be taken wherever there is a space constraint to maybe instead of a 1.5 breaker scheme, we go for a double bus scheme or a main bus and transfer scheme. Some sort of new thinking has to come in to overcome this challenge of land. And last, of course, the digital substations, which is the way forward in the future. I will not go much into digital substations. I think my colleague from GE, the co-panelist from GE, who's there, he would probably have give a better presentation on that. So this is a conventional AIS substation. As you can see, there are a huge number of steel structures and large spacing between various equipment to meet the clearances, which are essentially dictated by an AIS substation. Clearances from a safety point of view and from an operational point of view, which are there. And so therefore, it is now becoming, what I've shown here is now the different alternatives we have. So this picture here gives a conventional indoor GIS substation. The disadvantage of this indoor GIS substation is that it involves a huge cost for the building which has to be built over there, along with the requirement of a crane which can carry a load of about roughly 10 tons. And maybe in the future, when more expansion is to be done, if there's no space in the building, then another PEB building has to be built next to it, thereby increasing the cost of the expansion. So one alternative is, wherever possible, probably we should start looking at outdoor GIS substations. Outdoor GIS substations are today the reality with epoxy coated finishes available, so that we can take care of any environmental conditions. And these outdoor GIS substations today, they're operational in India also. I think there's one in Chennai and one in Gujarat, which are operating very successfully. The other, of course, is a vertical GIS substation. The picture shown here is of a substation in Sona in Gurgaon district. And this is another option. As I said, by building this substation, Sterlite Power managed to reduce the requirement from 12 acres to 4 acres. But this obviously then has a cost involved with the building. The building has to be a 3-storied building and the associated costs which come with that. So probably one very bright option is the hybrid GIS substation, where we could have GIS modular equipment outside available, and this could be connected to conventional outdoor AIS busbar arrangements, which would lead to a lot of space saving as well as costs in this. This slide just gives an overview of a substation. What it shows here is that this is the outdoor equipment consisting of various switchgears, transformers, reactors, etc. And then there used to be a huge control and protection relay rooms there, and a lot of copper cabling used to come in from all these equipment into these relay rooms, and then these are then connected to the operators' areas, and maybe some data was sent to a remote load dispatch center. So today, what is happening with the digital substation is the need for this relay room is getting eliminated. We have more of bay control units coming in, and what is happening is something which looks like this, a digital substation, where all the copper cables are reduced by optical fibers coming in out from the switchyard, and these are then connected to various engineering and operator workstations, and also maybe connected to the remote load dispatch center. And what will this entail is that you can have no manpower at the substation. They can be totally unmanned, and from the remote load dispatch center, maybe 7 or 10 substations can be controlled at the same time. Moving on, what advantages these digital substations offer? Of course, some of them were mentioned by Mr. Sharma earlier. We are using optical fibers instead of copper cables, so more number of signals can be carried on these limited number of optical fibers. There's a much lesser footprint with a digital substation. The installation time is very small. So this is also very important now because so many renewables coming into the grid. These renewables are normally ready in 15 to 16 months, the generating station. So the transmission has to match that schedule. So that means our substations and transmission lines have to be completed in the same time schedule. And today, in fact, in most of the new TBCB tenders which are coming out, the completion period is shown as 18 months. So having a lesser installation time is obviously a great advantage for the developers. They are more reliable, they require less maintenance, and the restoration is relatively faster than conventional substations which we had in the past. But of course, this comes with a rider. For digital substations, there's a cyber security risk always present. So the cyber security has to be very strong to make sure that there is no digital attack on our grid from outside. We have seen in the past that these things have happened in some East European countries where their grids have been hacked into, and there's always a suspicion that whenever anything happens, some sort of cyber attack has taken place. So cyber security has to be very strong. And the second part is, with more and more digitization happening, what is happening, the operators or the substation engineers who are there, they are probably not as skilled at solving problems as what we had in the past. This is not to question the capability today, but it is generally the environment they are exposed to. So I think a very strong training program has to be in place for these engineers, so that they're able to identify problems and rectify them as quickly as possible, rather than always depending on the equipment supplier or the technology supplier to come and attend to these issues. Some other new trends which are there in substation today, which is happening, is site surveys are done through drone, thereby saving a lot of time. A complete substation, say about 40 acres, can be surveyed by a drone in about 3 to 4 hours of time. Then 3D models of substation can be developed. There are different tools available. For example, in BIM 3D, those tools are available, which can lead to a very fast generation of the BOQ also. And then other things like site development, there are now 3D tools available in the market, like AutoCAD 3D, which can be used for, instead of earlier, like the engineers used to use work using Excel sheets and AutoCAD, 2D AutoCAD to come to how to have different levels for a substation. Today, the 3D terrain profiling tools can do that in roughly 1/4 of the time. And of course, digital substation, which has already been mentioned. So other trends which are there in substation design, as I mentioned, hybrid gas insulated and air insulated substations are there. Short circuit current, which is a problem. So today fault current limiters are available, which can be put in substations, which will require the need of doing away with splitting of buses. And series reactors can be put on the line of the buses to control the short circuit levels. Online monitoring for the transformers with dissolved gas analysis. This would remove the need of constantly taking out oil samples on a transformer and sending it to laboratories for testing. Online PD monitoring for GIS to take care of any partial discharges which should be happening. And in some of the distribution substations today, we have prefabricated solutions. Some of them, I'm sure you must have seen, a lot of them are mounted in Delhi. Tata Power, I think, has also done a lot of them, where they're inside an enclosure. The enclosure is just come and put on a foundation and the substation is ready. Use of FATS devices. This could be different kinds of FAT devices. It could be SVCs, it could be series reactors, shunt reactors, to control the power flow in the lines and to give greater stability to the grid. And the other important thing is in GIS applications. Most of the GIS applications today use SSH gas, and SSH gas has been, it's a environmentally unfriendly gas and needs to be phased out by 2025. So a lot of green gases today are being developed by the leading companies in the world. Siemens, GE, and ABB, all of them are working on it. And all of them today, I think, have products available up to 400 kV with an alternative gas, which is environment friendly. So overall, as I said in the initial slide, today our grid is doing a significant transformation, and substations, which are an integral part of this, needs to keep up with these changes in the grid, and we need to be flexible in our approach to have a more resilient grid for the future. Thank you.